The mystery of the rare pentagon. Solve for x. It is my impression in geometry that there are a lot of math problems with triangles and not a lot of geometry problems in math that deal with traditional shapes that have more than 4 sides. However, that's not to say that geometry problems with a shape that has more than 4 sides aren't out there. So here is some math vocabulary for this problem. Geometry. Geometry is an area of mathematics that is about properties of space. Some specific examples of the properties of space in geometry are distance, shapes, lines, sizes, and angles. Pentagon. A pentagon is a 5-sided polygon that can either be a regular pentagon or an irregular pentagon and has 5 interior angles. Regular pentagon. A regular pentagon is a pentagon that has 5 equal sides of length and 5 equal interior angles. Polygon. A polygon is a closed 2D figure that has 3 or more straight lines. I think it is a fair assumption for a math problem that unless a math problem specifically states that the lines in a shape are drawn to scale, that the lines in a shape may or may not be drawn to scale. With that assumption, there is the idea that in finding a solution for the 5 x's with the degree symbol on them, that there isn't a lot of information to go on. However, there is a lot of information to go on. Let's start by setting up an equation to solve for x using 2 variables. There are 5 instances of x in this pentagon, so this can be written as 5x. While I can choose any other letter besides x for my second variable, I'm going to let y be the total amount of the degrees from all 5 degrees because of a helpful formula called the sum of interior angles. Therefore, I'm going to set up the equation of 5x equals y since 5x and y are the same. 5x equals y. So, what is the sum of interior angles formula that I previously mentioned? The sum of interior angles formula states that the total sum of all the interior angles of a polygon is equal to n minus 2 in parentheses times 180, where n is equal to the number of sides in a polygon. The n minus 2 happens first, then the difference of n minus 2 gets multiplied by 180. I wouldn't be surprised if there are SAT questions out there where it will be useful to know the sum of interior angles formula. To say how much the sum of interior angles formula applies to, the formula can even be used to find the sum of all interior angles on a qualifying shape that has 100 sides. In this math problem, I'm going to confirm that the sum of interior angles formula for polygons can be used on the shape in this math problem so that I can use it to solve for y. While it isn't necessary to confirm that the shape is a regular pentagon since the sum of interior angles formula works with both regular pentagons and irregular pentagons, I should confirm that the shape is in 2D, is closed, has 3 or more sides, and that the shape has no curves. Does the shape have 3 or more sides? The shape has 5 sides, so the answer to that question is yes. Is the shape a closed 2D shape? The answer to that question is yes, as the lines in the shape are connected and don't have any gaps and the shape is in 2D. Does the shape have any curves? All the lines of the shape are straight, so the answer to that question is no. Based on the answers to these questions, I have confirmed that the sum of interior angles formula for polygons can be used to solve for y in the equation that I set up, so I'm going to use the formula. The number of sides in the polygon is 5, so I plug 5 in for n in the sum of interior angles formula and get 5 minus 2 in parentheses times 180. In regards to the order of operations, the 5 minus 2 is in parentheses and gets solved first. 5 minus 2 is 3, so this becomes 3 times 180. Since calculators aren't allowed in some math tests, I'll use long multiplication to solve for 3 times 180 instead of a calculator. Long multiplication breaks down a big multiplication problem into smaller steps, 180 times 3. The long multiplication problem is set up. I multiplied the 3 by the 0 180 and got 0, which goes into 1's place for my answer. I multiplied the 3 by the 8 in 180 and got 24. The 4 from 24 goes into the 10's place of my answer. Next, the 2 from the 24 gets carried over above the 1 in 180. Next, the 3 gets multiplied by the 1 in 180 and gives me 3. But I'm not done, as I have to add the 2 that got carried over to the 3 answer I just got, which gives me 5 in the hundreds place of my answer, which makes me finish with my long multiplication with an answer of 540. 3 multiplied by 180 equals 540. Therefore, y and the sum of the interior angles for this shape is equal to 540. And after I use the 540 answer for y into 5x equals y, the new equation is 5x equals 540. To solve for x, both sides of the equation can be divided by 5. To account for tests where a calculator can't be used, I'll use long division, but before I get started with the long division, here's some division vocabulary. Long division. Long division is the method of solving a big division problem by breaking down the division problem into smaller steps. While long multiplication and long division aren't required to solve a lot of math problems, it isn't exactly easy to climb a staircase that has really high steps. Dividend. For general division math purposes, a dividend is the number or variable that is being divided by the divisor. It is commonly found to the left of the division sign on a division expression with two numbers. Divisor. A divisor is the number or variable that the dividend is being divided by. It is commonly found to the right of a division sign in a division expression with two numbers. Quotient. A quotient is the answer to the dividend being divided by the divisor. Remainder. A remainder in division is what is left over from a division problem that doesn't divide evenly. Remainders can have other applications in math besides division. Back to the long division problem, 540 divided by 5 has been set up with a division bar. 5 is the divisor, and 540 is the dividend. The quotient will go above the division bar. So how many groups of 5 go into the 5 and 540? The answer is 1, and that goes above the 5 and 540. Then the 1 in the quotient gets multiplied by the 5, and I get 5. That 5 goes below the 5 and 540. The 5 gets subtracted from the 5. 5 minus 5 equals 0. The subtraction answer of 0 goes below the 5 that is below the 5. Then the 4 from 540 gets brought down. So the 0, 4, and 4 is really the same thing. How many groups of 5 go into 0, 4? 5 is a greater number than 4, so the answer is 0, and that goes above the 4 in 540. The 0 in the quotient gets multiplied by the divisor of 5, and it gives me the answer of 0. The 0 gets subtracted from 0, 4. The column with the 4 from 0, 4 gets solved first, then the column to the left gets solved next. The answer from 0, 4 minus 0 is 0, 4. Then the 0 in the dividend gets dropped down, which gives me 0, 40. The divisor of 5 gets used again. How many groups of 5 go into 40 or 0, 40? the answer is 8, and that goes in the quotient in the ones place. However, even though I have the ones place of the quotient, I'm not done, as I need to do a remainder check, as I haven't confirmed that the answer is 108 even. The 8 from the quotient gets multiplied by the divisor of 5, which gives me 40. This 40 gets set up to be subtracted from 40. The ones column gets subtracted first, then the tens column, and then the hundreds column, which gives me my answer of 000 from the remainder check. Since my answer is a number that is equal to 0, there is no remainder. Therefore, the answer to x in the long division problem is 108. So each of the 5 degrees in this pentagon is equal to the same amount of 108 degrees, and since I'm solving for x without the degrees symbol, 108 is the answer. If you like this video, please like and subscribe.